Okay, this one should be pretty easy, pretty straightforward. Formation of the solar system. Our objectives. First thing, you're going to be able to explain nebular theory and the origin of the solar system. 2, you're going to be able to describe how the planets are developed. 3, describe the formation of the land, the atmosphere, and the oceans of Earth. Pretty straightforward. I think you'll be able to do it real quick. So let's make it happen. Here we go. Number 1, formation of the solar system. We talked about the fact that the solar system is everything that's in there. It's the bodies, the planets, the comets, the gases, everything, the dirt, the debris, everything that's out there. That's our solar system because it's going around our sun. That's the solar system. What do we think? Well, so right now we look at the 8 major bodies that revolve around the sun. You know, it used to be 9 planets, and then Pluto got kicked out because it wasn't worthy. But the reality is of the 8 major planets that go around the sun, the first belief was that the sun was throwing off the materials to make that happen, and this was back in the 1600s and 1700s, and so the idea was stuff came out of the sun to create the planets. Then Marquis Pierre Simon de Laplace, we call it the Laplace theory, basically said that everything that's in our solar system formed together. It was a spinning nebula. It was out of the gas and the debris that was left over. This is about 1796, and so his idea really became the starting point for what we now know is how it happened. Nebula, we've talked about this a million times, a cloud of gas and dust. That's obviously the first stage in the development of the star. So obviously we've discussed this. It's something that's been pretty hit pretty well with the things that we've talked about. Nebular theory. Okay, so this is Laplace's theory, and basically what it said was all that gas, all that debris, it spun around until it condensed. As it condenses, we form the sun, we form planets. Big Bang Theory. We've talked about this before. Basically, all of the material that's in the universe came from a small point, and it's expanding outward. All the gas, all the dust formed the solar system, formed all the solar systems. So again, from a solar nebula. Nebula means gas. A gas cloud that makes the solar system. What do we think? 4.6, 4.7 billion years ago, we see a supernova, and it causes everything to condense and collapse. And so what do we see? The start of the formation of the solar system. Increased heat, increased pressure, spinning gases. We get high temperatures, and fusion begins. We see a star is born. And so basically, that's when our stars started to shine. This is the gaseous pillars. Again, stars being born in 3 different places right along this thing from this stellar nebula. And basically, you're watching stars being born here. Protoplanetary disks right here. These are globules that are forming from material that's floating out there. Again, we're seeing the birth of planets. So, how do planets start? Small little bodies. We call them planetesimals. They're small, right? And so we start to see material come together, coalesce, and basically we see that material start the beginning of planets. Protoplanet. Okay, so we have a bunch of protoplanets, or a protoplanet is a bunch of planetesimals that have come together. They collide, they're breaking up, right? It reminds me of the big game Asteroid when I was a kid. And again, gravity is pulling these things together, and so as they do, they come together and they coalesce. Obviously, we keep hitting 8 planets. Pluto, that was discovered by Clyde Tombaugh from Streator, Illinois, not too far from here. Obviously, the the people in Streeter would like to see Pluto remain a planet, it is downgraded to a protoplanet. Moons, again, other material gets caught in the gravity of the planets as it's happening. Lo and behold, they come together and we see moons. Our moon, basically, when another planet slammed into us, and I can't think of the name right now, but slammed into us, when it did, that material moltened our planet, and like a prize fighter getting hit with a left hook, a globule of spit. Well, in this case, it was a globule of material that came out of the moon, or out of the Earth, as it did our moon. Luna formed the moon, and so it eventually solidified. Same materials on the moon are found on Earth. Here's protoplanetary disks starting to form. Why do we have heat in the Earth? I mean, it's pretty straightforward question. So, what are the sources? Well, first of all, we've been beat up. We've been hit by asteroids. We've been hit by different material whizzing around in the universe, and so it's hot from the collisions. Number two, if you've ever been in a dog pile, basically the more people you get on top of each other, the heavier and hotter it gets. Well, same thing, when we get that much material, we see increased pressure. Increased pressure causes increased heat. The other thing we have is radioactive, and again, we have a lot of particles, and if you look at the periodic table, a lot of radioactive elements out there. And so what's happening is they're emitting high energy. That's how our nuclear power plants work. We bring the nuclear material together. The neutrons bounce off of each other. The alpha, beta, and gamma rays hit each other, and basically we see heat as a result. So we can see that as well. Don't really need to go into too much here. You guys are experts on Earth, core, inner core, outer core, mantle, again, and the crust. You guys should be experts. You built this model. Our atmosphere. How did our atmosphere come about? Basically, it started with very, very little gases or no gases in the atmosphere, because we really didn't have a gravitational pull. But as gravity increased, then our atmosphere formed. Well, hey, shocking, hydrogen and helium, right? Early atmosphere. But then we see collisions and heat and explosions. And so what happens is we see carbon dioxide and water vapor. If you strike a match, you're going to see water vapor. If you strike a match, you're going to see carbon dioxide. Large explosions in the atmosphere. Very little oxygen, but then we get blue-green algae and plants, and these guys are sucking up the CO2 and basically putting oxygen in the atmosphere. Again, they become the next level for our atmosphere. Once that happens, Earth cools. Guess what? Water comes out of the air because it condenses. We have rain. About 3.5 billion years ago, we see a lot of water fall to Earth. 40,000 plus years, fills up the ocean. We see carbon dioxide being sucked up in the water. 1.5 billion years ago, we start to see our atmosphere like we see it today. So that was a quick run through, but I thought it'd be pretty straightforward since you guys have